Good afternoon, everyone. I'm Evan Patton. As Todd said, I'm the lead software engineer for MIT App Inventor. And today I'm going to be talking to you about a project we've been working on called Aptly, which enables automatic app generation from natural language. Now, App Inventor's mission really comes down to this idea of what if everyone were empowered to solve problems in their community via computation. And this is not a new idea. This idea has been around for many decades. MIT professor Seymour Papert had this to say about it when he talked about children programming computers. And back in the 70s, that was an insane idea. Computers were huge. Why would you let students and kids play with these things? Therefore, doing business and computing all sorts of stuff for the military. Kids should not be touching these things. But his vision was that if you give them this technology and they play with it, they will be able to gain mastery over it. And it's an extremely powerful technology they should know how to use. And then Professor Hal Abelson, the director of our lab, and a student of Papert's, coined this idea of computational action, where it's not just about programming for the act of programming, but empowering students to be able to create technology that will have an impact on the world. And we've had some success with this. This is usage we've had for App Inventor, users in pretty much every country and region on the planet. And the United States leads the charge, but I must commend you all in Taiwan here. Over 1 million people in the last year have used App Inventor to make applications. And we've had over 22 million people make applications with our technology. And here's just a sense of some of the things that people have built. There was a team of students who made an app for a blind student to help him navigate his school. We've had students who made apps to help elderly grandparents who are suffering from Alzheimer's remember to take medications and other important pieces of information. And we've seen girls make apps to help track water quality or to help with scheduling time at the well to help out their families. And it's not just students. It's not just kids. Here's a team of adults who used a convolutional neural network that they trained to detect dengue. So mosquito larvae get infected and then can pass on the disease, and they want to be able to detect those larvae so they could eradicate them and reduce the disease spread in Brazil. Closer to home here in Taiwan, a group of students at the Laodong Junior High School in Yilan County made an app to try to help farmers deal with excess produce. And just last week, they won a design award at the MIT AI and Education Summit that we hosted in Cambridge. So we're very excited for them for that. And overall, we've had 100 million projects people have built to try to make a difference, which is a fantastic, fantastic thing. Now, generative AI, we all know it's here. That's why we're here. And the question is how can we use generative AI to accelerate computational action for the next 100 million users? One way we've done this in App Inventor is we've introduced a component called the chatbot. And it's providing an abstraction over large language models. So it could be OpenAI, it could be Google, it could be something from Amazon. The student has an opportunity to play with it. And you can see here on the right-hand side how simple it is. In only 6 blocks in App Inventor, a student can make a fully functioning chat application. It takes 10 minutes. So you don't have to worry about writing a bunch of code. The system manages most of it for you, and you get to play, and you get to try things, and you get to learn. And as we heard from a number of speakers today, that is extremely important to really grasping the technology. So far, we've had over 25,000 people experiment and build applications with this, and they've done over 300,000 conversations with the chatbot to date. And as part of our way of trying to encourage this, We provide 10,000 tokens a day for free so that students don't have to worry about obtaining API keys or any nonsense like that. They just get to try things out and learn. The next way in which we're trying to think about generative AI is through Aptly. And for that, I'm going to play a video that shows how Aptly works.
I am so ready for lunch right now.
Oh, me too. I'm starving. Let's see what we have in here. Ugh, look at this moldy cheese. We need a better way to manage our fridge so we don't waste food like this again.
Yeah, that's gross. We should make an app to help us out. We can make an app just by describing it in plain language to a computer.
Really? Can you show me how?
Of course, but first, get rid of that. This is MIT App Inventor, a drag-and-drop blocks-based programming platform that lets users create mobile applications. We're making a new AI integration that allows users to create apps from natural language descriptions. Make an app to help us keep track of the items in our fridge. Now, Aptly is automatically creating the app for us.
Oh, cool. It created the user interface and code blocks for us.
Yeah, let's try it out. Now we can add items like this. And we can remove items like this when we consume an item. This will help us easily see what's in our fridge without having to rummage through the entire thing.
This is great. I think it would be really cool if the app could also give us recipe suggestions based off the food items we have in our fridge.
That's great. That would really help us make sure we're using all of our food before it expires.
Yeah, exactly. Make it so that when I click a button, the app will recommend a recipe given the ingredients in our fridge. Okay, let's see what we can make for lunch. Oh, cool. It recommended we make a peanut butter banana smoothie. That sounds delicious.
That sounds really good.
These smoothies are delicious.
And that's how you can use Aptly to create and customize MIT App Inventor apps to solve real-world problems.
Cheers.
So thank you to Ariana and Ashley for acting that out. Ashley was our master's student who worked on the editing capability of Aptly. She's now a software engineer at Apple, and Ariana worked on making it so it can make the user interfaces, as you saw in the video. Okay, so returning to this idea of abstraction and how App Inventor works with it, what we decided to do with this is App Inventor being a visual language, like you see on the left, makes it a little bit difficult for a large language model to manipulate it. So we defined a language, as you can see on the right-hand side here, that shows how to manipulate the blocks as text. And then we use a technique called RAG to aggregate many different application examples together. So we made an app that, how do you order something at a pizza parlor? Like, how do you pick ingredients? And that shows how to manipulate lists. And then we showed, for example, how to use the chatbot in order to create recommendations in different behaviors. And then how do you do things like text-to-speech and stuff like this. So Aptly pulls all this information together based on the embeddings that it derives from the user's input, and then feeds that through a large language model to produce the final output. And in terms of editing, the user is sitting there coding this app with App Inventor. They can give instructions via voice commands, as we saw in the video. Then what happens is the large language model produces a new updated version of the application. And then finally, we determine the differences in the program syntax tree to make updates. So rather than just inserting characters into a text language, we're dealing at a much higher level of abstraction to make the edits more efficient. And it's not just restricted to simple interfaces. Kids love to play. And so what we want to do is make it so that they could engage their creative nature by making things like games. So here are some examples of prompts that you could give to Aptly, and this is what it will produce on the right-hand side there. The other really interesting thing about this is because we are leveraging large language models, you're not restricted to providing instructions in English. So here's an example of an app that we were making the other day at the summit. We're just playing around. We made a little app where you could vote for different cakes. And then this prompt, which I just got from Google Translate, I don't know Mandarin, so I didn't write it, produces this output. Right? And so if you find an app that might be relevant to you, you can customize it. You can pull it into App Inventor. You can tell it in your own language, hey, rewrite this, and it'll do it. And then the last thing we're thinking about with respect to using generative AI and app building is how do you scaffold how the application works in terms of looking at your user base, like who's your target user? Students need to think about, what is the pain point that they're trying to solve for? How many people are going to use this app? All of these different things can be used to help them scope what they're going to build. And then it will provide prompts that they can use in Aptly in order to generate the final application. Now, this has a lot of implications for education, which is our primary market. People are definitely concerned, if we do this, is it going to take away from what the students are learning? And of course, we're really interested in students trying to solve personally relevant problems. And we believe that this does lower the barrier and that they will engage with the technology because they can see the effects more immediately. The second thing that's interesting here is, will they continue to learn all the different computing techniques they need to be successful by watching how the AI does it, or maybe because it's doing it, they won't pay attention, right? That's obviously a concern. So this is an open research question that we're interested in seeing how it plays out. And then thinking about this, what I call the human AI symbiosis, right? The AI is good at doing a lot of things, we know that. But as a human being, I can look at a problem and understand how people feel about it, how a solution might make them feel, and it's very difficult, I think, for AI to really capture this. And so from the human perspective, we can bring a lot of value in terms of these tools. But it requires us thinking about how we adapt our assessments of what students are doing in the classroom. And then lastly, looking towards the future, we're going to look towards the past and what Seymour Papert was saying. Back in the day, computers were huge, but it was still relevant for students to learn how to program them. And today, of course, many of these large language models that students are engaging with are run in data centers. And so we're kind of here right now when it comes to Aptly. What we're actively working on at the moment as a team is seeing, can we get these models to be good enough so that they can run on a laptop? Because then you don't have to worry about the data center as much. You can spread everything out more evenly. More people will have access at lower cost, and that will make a big difference. But ultimately, we want to be on the right. We want to be here on the phone, because this is where most of the world is interacting with technology. In fact, 3.5% of App Inventor users do everything entirely on their phone. That's an incredibly impressive number because, of course, the interface isn't designed for that. But maybe if we could get these models running on the phone, maybe it's just a matter of speaking to it. Hey Siri, make me an app to help keep track of my refrigerator contents. And maybe we can do that all offline so that we can take these tools and bring the technology into remote areas where people otherwise would not have access to these large language models and still make a difference in their lives. So if you're interested in getting involved with any of this work, I would definitely ask for you to check out RAISE, which is an initiative under which App Inventor sits. It's the Responsible AI for Social Empowerment and Education initiative. And we run 2 really major events that you can participate in. The first is dayofai.org. This is a program run every year. Teachers can sign up to get materials and then teach AI in their classrooms. We've reached over 10,000 classrooms so far through this program, and it's a great opportunity for teachers to teach generative AI. The second is an event I've already mentioned, our AI in Education Summit. We held it last week. It will be held again next year. And we brought together people from industry, from government, from research, and we had teachers and students as well, all participating and discussing the challenges and opportunities around generative AI in education. And ultimately, here's where we are and here's where we're going. Our computational action mission has empowered people of all ages to make interesting apps to solve real-world problems. We've shown that we can use this bidirectional system to allow large language models to manipulate apps. And then ultimately, we believe that these technologies can be used to lower barriers of entry so that everyone in the world will be able to solve problems through these technologies. Thank you.